Howdy, I'm Professor Curtis of Aspire Mountain Academy, here with more statistics homework help. Today, we're going to learn how to find conditional probability from a frequency table. Here's our problem statement. In an experiment, college students were given either 4 quarters or a $1 bill, and they could either keep the money or spend it on gum. The results are summarized in the table. Compare parts A through C below. Okay, part A asks us to find the probability of randomly selecting a student who spent the money given that the student was given 4 quarters. Conditional probability is calculated by looking at the probability of both events occurring and then dividing that by the probability of just the one event occurring. To do this, we can actually leave our data here in the table. We don't have to dump our data into any third-party software. I'm actually going to put the data into Excel because Excel makes this kind of nice for our purposes, and I'll show you how nice it can be here in a moment. You can work the problem in StatCrunch, but the problem with working it in StatCrunch is that for this type of application, StatCrunch is actually pretty clunky and awkward. You can do it, but because it's so awkward to use StatCrunch, I'm actually going to use Excel. So we'll open up Excel here. All right, so here's my data here in Excel. Whoa. Oh, wow. Yeah, okay, so that's a different problem. Let's actually move you over here because I think, yes, that actually matches. Hey, where are you going? Stupid window. Go where I want you to go. Yeah, let's actually put you right here. And yes, let's get rid of you. What are you moving back here for? Why can't you be where I want you to be? Quit trying to think for me. Do what you're told. Okay, here we go. Now we're ready. So now I have the data here. So we want to find the probability of randomly selecting a student who spent the money, given that the student was given 4 quarters. Okay, well first the probability of both. The probability that you both spent the money, which means you purchased the gum, and that the student was given 4 quarters. So 4 quarters is this row. So the point where they both intersect is here's the 26. So that's going to go on top. So we're going to take 26 and we're going to divide that by the probability that the student was given the 4 quarters. Well, how many students were given the 4 quarters? This is where Excel makes it really nice because all I have to do is just select the cells for that given category, given the 4 quarters, and then down here, Excel actually sums up everything really nice for me. Sum is 42. I can get the same thing in this calculator just by using the parentheses. See, there's my 42 all the same. But either way you work it, this is why I say you don't really need any third-party software. You just need to know which numbers to put in, and then you can actually get out, there's your probability. I'm asked to round to 3 decimal places. Fantastic! Now part B asks us to find the probability of randomly selecting a student who spent the money, given that the student was given a $1 bill. Okay, so same calculation, but just slightly different numbers. So again, we want to get the student who spent the money and was given the $1 bill. So spent the money and you were given the $1 bill. That's going to be the 19. So 19 divided by, and then how many were given the $1 bill? 47. There's my probability. Again, I'm asked to round to 3 decimal places. Nice work! And the last part C, asks, what do the preceding results suggest? Well, before we look at our answer options, let's go ahead and look at what the preceding results actually are. So here we've got 2 probabilities. They're both probabilities for students who spend the money, but the condition is the thing that's different between them. So in this case, the probability that's higher is associated with having the 4 quarters as opposed to the dollar bill. So what we see here is that if you're going to spend the money, it's more probable you'll spend it if you actually have 4 quarters as opposed to the dollar bill. Okay, let's go back and look at our answer options, see which one matches what we've just learned. Answer option A says a student was more likely to have spent the money than to have kept the money. Well, we didn't do any probabilities with keeping the money, just the probabilities of students who spent the money, so that's not going to be right. Answer option B says a student given 4 quarters is more likely to have spent the money than a student given a $1 bill. And yes, that's what we learned just a moment ago, so I'm going to select that. But just to make sure, let's check the other answer options before we check our answer. Answer option C says a student given a $1 bill is more likely to have spent the money. No, we don't. That's not what this is saying right here. It's actually the reverse. And then answer option D says a student was more likely to be given 4 quarters than a $1 bill. Well, the problem statement doesn't say anything about how students were selected for each of the categories or groupings. It just says that they were selected. We presume that it's random, but we don't really know because there's nothing about it that's said in the problem statement. So it looks like answer option B is the one we're going to go with. Well done! And that's how we do it at Aspire Mountain Academy. Be sure to leave your comments below to let us know how good a job we did or how we can improve. And if your stats teacher is boring or just doesn't care to help you learn stats, go to AspireMountainAcademy.com, where you can find out more about accessing our lecture videos or provide feedback on what you'd like to see. Thanks for watching. We'll see you in the next video.